Hey there, this is Seth Wires from Channel 9 coming to you from NDC Oslo. We're here in the beautiful country of Norway with all the festivities. It's day 3. You just saw Troy Hunt talk about security, I'm sure, but I'm here with a special guest to talk about a topic that I've actually wanted to get into. Why don't you tell us who you are and what you do?
My name's Elton. I'm an Azure MVP, I'm a Pluralsight author, and I work for Docker. So I'm going to talk to you about Docker.
So let's talk a little bit about what Docker is. Like if you've been living under a rock and you finally emerged, to see if you could see your shadow, what is this technology, number one, and why is it very exciting?
So when you crawl out from your rock, you will see this whale.
Of course.
The Docker icon everywhere.
Huge, yeah.
So what Docker is, it's virtualization at the application level. So if you imagine the history of computing, you started with a server. You've installed an operating system, you ran your application, fine. That's problematic if you want to run lots of applications because they might interfere with each other.
Sure.
So then we have machine virtualization. So I take my big server and I run a whole bunch of virtual machines on there. Each of those virtual machines are its own operating system. There's a whole lot of overhead around that. So I've got to run my application, I have my application, I've got my fake operating system, and then I've got my real operating system. But I can get isolation between my workloads. So what Docker does is it takes out the middleman. So I've still got my application running, I've still got isolation because I have this boundary around it, and that's called a container, but I don't have a virtualization layer, I don't have an operating system in between.
So it's like a thinner VM.
Exactly. So a machine that could run maybe 6 VMs, you could run 100 containers, 500 containers.
Now how does it go through the process of, because I imagine there's several processes running in a container, how does it go about isolating them so they can't interfere with each other?
So Docker emerged from Linux, where some of these primitives to be able to say these processes, group them together so they can see each other but nothing else can see them. So that's existed in Linux for a long time, and Docker came along and took advantage of that and made it much easier to do that stuff. And then that came into Windows in Windows Server 2016. So Windows Server 2016 has the same mechanism to say these things are isolated within a container.
That's pretty cool. So how do you go about, so if I have an application, do I just take it and put it into a container? I suspect you can do that, but that might not be the right thing.
Exactly. There are two options. So you can, when you put an application into a container, what you do is you build an image. You package your app up into an image, and you write a really simple script that says, here's all the things I need to do, and then you execute that script, and the output is your whole application packaged up, all your configuration ready to go. That's a portable thing, so you can share that somewhere public or somewhere private, and anyone can run your app. You can, when you build that script, you can take your existing artifacts. So if I've got an MSI from a hideous build process that with thousands of lines of XML, but my MSI does what I want, I can put that in my Docker image. So in my Docker, I'll show you this. In my script, I say, here's my MSI, execute that, and the output is my application installed in my image. I can run that in a container. So I don't have to do anything new. There are some disadvantages with that. The main one being that your script, your deployment script, called a Docker file, that thing should be every step you need to do to deploy your application. It should be the definitive deployment guide. And if you've got an MSI in there, then all that stuff's opaque. You don't know what's happening in that MSI. So you can look at your Docker file, you can't see what's going on. Right. So the next step is to instead of using your MSI, to break it up and do like an Xcopy deployment, but in your Docker file, you can see exactly what's going on.
I see. So let's talk about images, because before we get to this, because I want to see what you're describing, because that's probably the best way for me to learn. When we talk about images, there's this notion of base images. Is that a thing, or did I get that wrong?
No,
what is it all about?
That's right. So when I package my application, I write this Docker file, and the first thing I say is, what image am I starting from? I have to start from something. It's like you might start from Windows Server Core. So that is an image that Microsoft own. They publish that on Docker Hub, and every month when there's a Windows update, they release a new version of that base image. So if you start your application from Microsoft Windows Server Core, you're effectively starting from a clean, fresh install of Windows Server 2016 without the UI, and then you can do all your stuff on top of that. And that's your base image. But you can then install all your stuff, but that could be somebody else's base image. So you can build things on top of that. So as well as the Windows Server Core image, there's an IIS image from Microsoft that's got the web server installed. There's ASP.NET that's got ASP.NET installed, and then you just add your stuff on top.
So there's like base images with just OSs, and then people build on top of that to create a new derivative base image.
Exactly.
And eventually you get your application where it could be a base image for your app, and you can deploy it.
Exactly, and you can choose what you do. Docker doesn't care. If you want to, you can go all the way back to Windows Server Core, you can run PowerShell scripts to add IIS and install ASP.NET, or you can use Microsoft's ASP.NET. It's whatever fits in with your process.
But it would be more clever to have a really defined base image that gets you nearly to where you are, and then you can make an image for your application.
Yeah, exactly. So imagine if you deploy VMs at the moment, if you're in a big enterprise, you've probably got your own certificate authority.
Sure.
So you will probably install your certificates when you provision that VM. Well, in the container world, you might still want those certificates. So you would have, I'm going to use the Microsoft image as my base image, install my certificates, and that's my base image.
Right.
And everything I build from that will have the stuff that I need everywhere.
Is there a way to version images as well?
Yeah, exactly. So you can there's like a default image version, which is latest, which will always get you the most current one, or you can specify whatever versioning scheme you want, like an explicit version number or a Git commit ID or whatever works for you.
Awesome. Well, let's get into how you do this.
Okay.
Why don't you describe what you're showing us?
Cool. Okay. So what I've got here is a Docker file. So this is the script that deploys my application, which happens to be an ASP.NET Web Forms app. This is not just for greenfield microservices, .NET Core stuff running on Linux. You can take your existing .NET apps and run them in Docker like this.
So this is a Docker file then?
This is a Docker file. This is my script. So it's pretty simple. What I'm doing is I'm starting from, so that's the image I'm going to base everything off. And in this case, I'm using Microsoft's image, which is ASP.NET, built on top of Windows Server Core. And like you say, I can put a version number in here. So I'm tagging a specific version of Windows.
Got it.
That happens to be the April release. But by doing that, every time I build this, I'll get the same output. Exactly, yeah. It's a repeatable Docker file. So what I'm doing in here is I'm switching the shell. So I'm saying that all the commands I run from now on, I want to use PowerShell instead of the default command line.
Got it.
And then I start to build up my application. So the first thing I do is I disable the DNS cache, which is an interesting thing because most Docker files in Windows have this. So as part of the Docker platform, when I run a container, so I've got my web application, maybe I'm running SQL Server in a container as well. Mm-hmm. When the web application tries to connect to my SQL Server container, it will use the host name, it will use the container name. I can call whatever I want, like MyDB. The trouble is when Windows does that service resolution, it uses DNS, it goes to a DNS server. Now that's built into Docker, so you get an immediate response with the kind of virtual IP address of the other container. Trouble is, Windows has got quite an aggressive DNS cache, and it will cache that IP address, and you don't want it to do that.
Right, because it might change a different environment.
Exactly. Yeah. So if the container goes down and comes up somewhere else, it'll have a different IP address. So what this does, and this is interesting because it shows you can do any kind of wonky stuff that you need to do for your 10-year-old application, you can do it in a Docker file too. So all I'm doing is running some PowerShell to turn off the DNS cache. So that's all that's doing. Incidentally, this Docker file, all the stuff I'm showing you is on GitHub on my repo. You can check all that stuff out. So then I'm telling Docker what to do when I start a container. So this will build me, the Docker file builds me an image, which is the package of your application. When you run a container, you start like an instance of that image. And this tells Docker what to do when you start a container. So in this case, I'm running a little PowerShell script, which will start up IIS and make sure it's running. And the last thing I do is copy in my MSI, my existing web forms MSI from whatever process I've got, and then I run MSI exec to start that process and deploy the application.
So where is it getting the MSI from?
So that wherever I build this up, wherever I do my Docker file, wherever that lives.
Oh, I see. Got it.
Okay, so you would execute this on your build server or locally on your laptop to see what it looks like. And the output is a Docker image. So I've already built this image, and I can run that. The way you build it, you can actually do it from Visual Studio Code. I can right-click and do Docker build image, give it a name, and that will just execute all those steps. And the output is this. Logically, it's one big file that contains everything my application needs. I could run that by doing Docker container run, but this one has a dependency on a database, has SQL Server dependency, and I haven't got SQL Server running on this machine. So rather than install SQL Server, I can run SQL Server in a database.
Right.
So what I've got here in my Docker component, so the Docker file is deployment for a component, a component in my application. Docker Compose is about having a distributed application.
So there'll be multiple containers.
Yeah, every component runs in a container, and I describe it in this Docker Compose format. And what I've got here is I've got my database that's running from SQL Server Express. Again, that's a Microsoft-owned image, it's kept up to date, I don't have to do anything to use that. I'm exposing the port so I can connect to it from the outside world. So from my laptop, I can open SQL Server Management Studio and connect to the container, like a remote database. And I've got a couple of things here saying, like, I accept the license agreement because it doesn't start if you don't do that. And a file telling it where my credentials are. And then I've got my web application. And this is the image that I've built from the Docker file we've just been looking at.
Okay.
And that's saying that it's got a dependency on that database container. So Docker will start them in the right order. And it shares that credentials file. So it's got the connection string to be able to connect with all that stuff. Okay, so that's how I describe my distributed application.
Got it.
Now I've already started this, so what we'll see here, I've got Docker for Windows installed, which just gives you this handy little whale icon, that's what everyone needs now.
Yeah, and I have it running on my machine.
Oh, I'm glad to hear that. So I've got my containers running, so I can do a container list, and we'll see those two. I've got two containers, one from SQL Server and one from my web application.
Perfect.
Now you can give any resource in Docker, whether it's a container, an image, a network, whatever, they all have a friendly name and a randomly generated ID. So if I want to find out something, I can use either of those. So if I want to look at my web container, I can do docker inspect 773, which is the part of the container ID. And I get a whole bunch of stuff about what's going on in this container, including this virtual IP address. So I can connect to that as if it's another machine on my laptop. And actually, I've already got that running. So here's my application, which is like version 1 of my rubbish application in my MSI. So don't worry about what it is. It's just a sample app that I use all the time. What this does is it connects to SQL Server. So when I click sign up, it's a fake newsletter sign up application. So I can put my details on. This information here comes from the database, so I know they must be connected.
Yeah, it's working.
And actually, this is NDC Framework code first. So when I first start my container, it'll connect to an empty SQL Server instance. It'll deploy the schema, deploy the seed data, and get all this stuff up and running.
Got it.
So that's our kind of entry point. That's it's not perfect because if I look at my Docker file, I can't. This could be doing anything.
Yeah.
I can guess it's a web application because I'm using ASP.NET, but this MSI, I don't know what's going on.
Yeah, it's a little opaque.
I don't know what ports are in there. I don't know where. Like as it happens, I'm using a virtual directory, but that's not clear from the Docker file. So what you would then do, that's your starting point. I've got my application running. I can see how the Docker stuff works, and from now on, I can start to break it up. Break up that monolithic application, and that's what I do as like a workshop or a demonstration of how you take these things apart and run them in other containers. And rather than going for a full-on microservice re-architecture, which a lot of old applications aren't going to get the investment for that.
Right.
I do it feature-based. So I've got a feature that's performing badly. Maybe I can take the component out, run it in a different container, and put a message queue in between. So I can smooth out peaks. I can get a more consistent performance. Maybe there's a component which changes frequently. So rather than do a full release of my monolith with all the testing that needs to happen, I can put that in a different container. And then when I need to do an update, they can have different deployment release cycles. So that's the sort of thing. And ultimately what I get to is a new version of my Docker file for the same application, but I'm starting with ASP.NET Windows Server Core.
You're setting the cache like you did before.
Yeah, as before. I'm using a later version of Windows, so this is how I deal with a Windows update. I don't connect to a container and do Windows update because the container is meant to be throwaway. It's meant to be disposable. Exactly. So when I've got a Windows update to do, I rebuild my image from a new specific version, and then I get all the latest stuff in it. So I turn off the DNS cache, and then I'm removing the default website and creating my own web application. So I've got, I'm looking at port 80. I can see exactly where it's deployed. I know that application directory will be there because I've just created it.
Right.
And then later on, I copy in. I'm doing like an Xcopy deployment here. So I've got a step which compiles my application, and I copy the published website into my known location.
So can you go up one more time, a second? There's something. What's the health check?
You've got a keen eye.
Thank you.
So the health check is when you start a container, Docker will monitor the process that's running inside the container. So in the case of ASP.NET, there's a little process that watches the Windows service and makes sure it's healthy, makes sure IIS is still running. Now IIS still running doesn't mean my app is healthy.
Right.
It could be up, but I'm returning 503 to every single response, which is no good. What the health check does is it tells Docker how to check the application is actually healthy.
And that's out of the container.
No, that's inside the container.
Oh, I see.
So this runs inside the container every 5 seconds. You can configure that. It runs this PowerShell command, which just does a local invoke web request. And if I get a 200 response, that's fine. Return 0 means tell Docker everything's okay. Anything else, it's bad. The application's not healthy. And Docker can react to that. So if I was running in a cluster with several instances of my container, if one of them went bad, Docker would take it down and bring up a replacement somewhere else. So that's how you do that stuff. It's also really useful for things like caching. If you've got expiration-based caching, if a user comes into your application and they hit a cold cache, they're going to have that.
It's going to take a long time.
But if you've got a health check running every 5 seconds, the chances are
it warms up your application.
So that's really this is a more advanced. It's still not particularly. There's not much going on here. There's 37 lines.
Right.
And actually, right at the top here, I've got another stage where I'm doing the compilation. So I'm using another image that's got MS Build. I copy in my source code and I do my NuGet restore on my MS Build in the same Docker file.
And you're building it in a separate container or the same container?
This first part here is like a throwaway image. So I'm using that just to compile my app, and the thing that I care about is this second one, the application image, where it packages my application.
And that's interesting because I've heard Jeffrey Snover is a guy that worked on PowerShell, and he's like, you need to start treating your apps or your VMs or your containers like if they were cattle.
Exactly, yeah.
Right? You don't give them names, because then you get attached to it.
Exactly.
And so here you're using, the example that I'm seeing is you're literally using a container to build it, and you're throwing it out.
Exactly, that's exactly right. And the other advantage of that is that's portable now. So I can commission a CI server, a worker agent for my continuous integration. I don't need to install Visual Studio or MS Build or anything other than Docker, because anyone who's got Docker can use this, and it will build the application in the same way. So I could spin up a VM with nothing on it but Windows and Docker, do my deployment, build my image, and then throw the VM away as well.
That's amazing.
So this gives me a more usable Docker file, and then the corollary to that is a more advanced application.
Right, because you're going to have to tell it when you compose to start this one up to build, and that one has to go first, then you have to build this other one.
Exactly.
And then you're going to throw that other one out. Okay,
yeah.
Cool.
But now I've skipped on a few versions of my application, so I've got a load more features here as well. So I've still got my database that's running the same way. I've got version 1.3 of my application, which has got some new features. I've got a whole bunch of other stuff in here. So I've got that message queue that I talked about.
Which is another container.
Another container. So when my web application, when people sign up now, instead of talking to the database directly, it'll drop a message on the queue, much more responsive and scalable. And then I've got message handlers that listen on the other side of the queue.
Got it.
This guy is going to listen to that message and it's going to do the saving to SQL Server. I've got Elasticsearch, so I've got another database. So I've got a transactional database, SQL Server. I've got a reporting database that I'm using Elasticsearch for, and a front end to that called Kibana, and then another handler which gets same copies of the messages and puts it in Elasticsearch. So you're getting a very condensed version of this demo. So I've gone from 2 containers, my web application and SQL Server.
5 or 6 different containers.
Exactly, and by adding all these extra containers and breaking up these features, I can now deploy them at different cadences, I can scale them independently, I can do all sorts of cool stuff like that.
So your Docker file describes all the images. Your Docker Compose describes how they all fit together.
Exactly. Okay. Your Docker file is one image, one image at a time. So I've got one Docker file for my web application. I've got another Docker file for my message handler. Yeah, all that stuff.
And it might just be that one of your Docker files is just an image. You're just calling out to another image that's already pre-built.
You might not add anything to it. And actually, for this compose file where I'm describing my distributed application, these are all public images that are on Docker Hub. So if you wanted to run this, you just need this file. And you do Docker Compose. So that's how I would also do my upgrade. So at the moment, I've got a few containers running. If I do Docker Compose, point it at my version 1.4 file, and start my containers up, -D means put them in the background.
So as this is running, the question I have for you is, obviously there's some data that all of the containers need to have access to. Is there a way to do that?
Yeah, so the way I'm running my containers, they are completely disposable. So SQL Server is the main thing. It's the only SQL Server and Elasticsearch are the stateful components here. When I create my container, it stores data internally, and if I throw it away, that data's gone.
Yeah, of course.
But there's a notion of volumes, we call them volumes, which is a separate data store. So I can run my SQL Server container, I can point the storage location to a volume, and then that's the data stored outside of the container.
Right.
Still within the Docker platform, but outside of the container. So I throw that container away, maybe I've got a schema upgrade, I start a new container, but I point it to the same volume, it's going to inherit all the data from the previous container. So that's how you get your consistency.
I see, okay.
So what happened here when I did this Docker Compose is it's checked what's currently running, and it's checked what's in my structure of my Compose file. So it's seen the database hasn't changed, so that's fine. It creates all this new stuff, and anything that was dependent on any new stuff gets recreated. So I've got a new application, a new web application.
Got it.
So let's clear this down. If I do a Docker inspect,
it should be like 5 or 6 things running now.
Yeah, I think there's 8 by the end of this. By the end of all these demos. Okay, so that's the IP address for my new version of my application. Oh, let's not put that quotation mark in there. Okay, so here's my newer version. So I've done a nice UI refresh. I've got a nice plug for our conference coming up.
We have like 60 seconds left.
Okay, cool. And what this does, everything's deployed from that one file, and I can deploy that consistently anywhere. So I can do a nice little thing here, and I can go and look at a swarm that I've got running in Azure, and I can have a look at my services, which I've already started. 60 seconds. And I've got the same application running up in Azure. So this is going to connect, and I can see all those same things in there. If I look at Azure, I've got a portal here for my worker nodes. So because the containers all run in the same way, but on they're platform independent. So I can run them in Azure. I can have all my good Azure stuff, but my same application running. And when I click on my link, then I've got exactly the same app running up in Azure.
That's amazing. So we have learned, and this has been really fast. It's been really, really important. We learned all about Docker images. We learned about how to compose them together. We learned about upgrading. This has been really informative. Thanks so much for spending some time with us.
You're welcome. Thanks for having me.
Thanks so much for watching. We have a session coming up, and then we'll be right back. We'll see you in about an hour.